judging criteria. So remember a while ago we talked about, I believe, the how do we add the score, right? Well, here in the prompt, you tell it, give more importance to this part of the judging criteria. And that's what's so cool about this. Like before OpenAI or AI or any LLM, you couldn't really do something like this. This is like having a little agent, a little assistant that'll go out and get the best results for you. Pattern match, solid versus plain, color family, fabric, and field. So I won't go through the whole list. You can always look at the code down the road. But look at this, return strict JSON only with keys, top 3, array of 3 objects, item ID, score, and why. So this is cool. So what we're going to do is we're going to ask OpenAI, return those 3 elements, but then tell me why you think. So that's pretty cool, right? It'll tell us its reasoning behind it. And then one short paragraph explaining the trade-offs. So here you'll see the gateway. What we're going to do here, this is for item 3910. All right, so 3910, I forget what address it is, but we can see. But what it's going to do is when we're going to send the recommend to the gateway, we send in the ID of the exemplar and the cleaned query results. Right, so we cleaned the data out of Aerospike. We did a projection. We did a query and just send those items. And then what we'll do is we'll look at the results. So now if the run selected, run all, where's the run all underneath? Run selected, cell and all below. And there we go, we got another, item, that's fine. Doesn't surprise me, the demo gods have not been nice to me in the last sec, so let me just try this Jupyter notebook again. So just give me 1 sec here. Yes. Notebook. All right. So run. Okay. So the code is running. It's calling out to OpenAI, and here's our response. The top choice was item 4756 due to its formal subcategory error match despite the solid pattern. Item 5129 was selected for its error and play pattern, though the silhouette is less aligned. Item 2533 offered a good silhouette and pattern match with a slight error deviation. So it sent us the 3 results with the score and the why, right? So we just built a recommendation engine without any ML ops or without any custom code on scoring that we would usually do. And here we're just using the LLM and being able to use some augmented information that we sent to it to bring back the best results, right? Now again, in production, depending on the number of API calls, you might want to store some of these results in the database or directly, right? Maybe get the top 10, run them in a batch, and then store those results so you're not always using the OpenAI key or the API key because you'll be throttled after a certain while. And also, those API calls do cost a lot of money over time. But this just goes to show you a little example of how it can be used right there. Now, so that was the demo, so I'm just going to go right back here. So before we continue in this first part of the presentation, any questions on what we've just seen? Is this an approach you'd already noticed? Is this a different way of doing it? Comments or questions?
I'd like to understand more on the storage.
Yes, and we will. We'll be talking about the technology of Aerospike, how we store the data. We'll be also going through another demo also after in the second part using graph databases also. But we'll be able to talk about that a bit more for sure.
Good question. So you mentioned about the the feature store aspect, right?
Yeah.
So how big of a deal is that? Like, is it? And I'm just trying to see from a comparison standpoint, like other databases like MongoDB and stuff, right? Do they also cater to those kind of features?
Yeah.
Inbuilt or?
Yeah. So the thing with a feature store, you can store features pretty much in any type of database. It can be NoSQL, or relational, right? Now, the big deal is for an offline feature store where you're going to be doing a lot of batching and inference on the data, which is not in real time, well, they might be able to handle it. But if you need an online feature store where, let's say, milliseconds count and throughput and scale count, well, then a lot of the competitors start falling off, right? And that's what makes Aerospike so different. And that's why our scale and our throughput become a great, great example for an online feature store and a great solution for it too. Gotcha? All right. So we talked about recommendation system approaches and hybrid strategy. So the best is, if you're going to production, having both a good mixture of both content and collaborative filtering. Hybrid recommendation at scale, again, this is where Aerospike shines for online, because in the demo we only showed the content filtering, but in reality, if you're using machine learning models, etc., with offline feature stores and online feature stores, and the hybrid approach, this is where Aerospike also shines, right? So we showed a very simple use case, a simple case here, but when it comes to being able to process petabytes of data at very, very low latencies, that's where we come in at scale. So, who are using us? Well, we've got some pretty cool clients already, right? So we've got Sony Interactive, who actually use Aerospike in the background for everything related to their PlayStation network, right? So recommending certain games, so you log into the PlayStation network and you just played a pretty cool game, and all of a sudden it looks at the games you played in the past, some of the games which are trending. It probably compares some of the gamer profiles which are very similar to yours and then recommend those, right? So just to tell you, the challenge, personalized decisions for 100 million active PlayStation users, right? So it's a lot of scale right there in people. Solution Aerospike powers a real-time machine learning platform for user personalization, right? So 8 million transactions per second and 12 times faster data access. And as we'll see down the road, what's really cool about Aerospike is that you'll learn that we do this so fast at petabyte scale, but on a smaller infrastructure spec than most of our competitors, which is even a greater benefit there. PayPal, lowest latency and highest throughput. So we're using PayPal to help with their fraud detection algorithms. So PayPal needed to be able to, when it comes to fraud detection, the more data that you crunch for your risk score, the better the predictability will be. Only Aerospike can store the amount of data needed for them to have an acceptable risk tolerance and score. And just to tell you the way it worked is once they did implement Aerospike, not only did they were they able to process much data faster, that risk reduction represented tens of millions of dollars in reduced fraud per month. And an 8 times reduction in server footprint. So that's even more, like doing more with less, that's what we do at Aerospike.
Did you notice that the majority of the fraud was coming from just a large chunk of repeatable offenders that were hammering what they perceived to be a security hole, and then that's what you guys solved, or where did that noticeable?
Yeah, that's a very good question. The reality is I don't know too much about the inner workings of the fraud, about how they implemented it or what was the context around it. But all I know is that when it came to really predicting fraud, they needed much more data than they could currently handle in their current database, right? So, but what you're mentioning is true, right? I think a lot of that plays into it, right? But yeah, the more data you can crunch and use, the better your scores and predictability will be. And finally, LexisNexis, so they had predictable performance and rising costs with Cassandra. So they had a 96 node Cassandra cluster that can scale like efficiently. They had some latency and high costs and complexity with 450 terabytes and growing data set, right? So once Aerosprite was brought in, not only did speed and latency improve by 4, the reduction of servers, that's where it hits you, right? They went from 96 nodes to 28 nodes total, saving 3.3 million in infrastructure over 3 years and having a database that can actually handle the scale and the load that they needed. And that's it for now. We're going to take a little break, everyone. I'm going to drink a little bit of water. And if you have any questions, let me know. Tess, how many? 10? 15? 10?
Oh, you know what? Let's do like half an hour just to grab, like everybody can grab
Oh,
lunch.
perfect. Yes.
And then give you a break too.
Yeah, that'd be good.
And yeah, maybe we'll reconvene at around like, you know,
Perfect.
1:15.
Yes. Yeah, so after what we're going to do, we're going to talk about the technical overview of the database. So that'll help answer some of your questions with the hybrid memory architecture and do another little demo using fraud detection graph databases. Thanks, everyone.
Anna, thank you for inviting me. This is amazing. LOL. LOL.
I mean, we don't do shitty content.
LOL. LOL.
Oh, thank you. That's so nice of you.
For the top, the volume, you can order it now, just let them know.